All right, so if we have, in Charles' law, temperature and volume respond to each other. Temperature goes up, volume goes up. Temperature goes down, volume goes down. The result is that the relationship between volume and temperature always produces a straight line, and the straight line intercepts at 0, 0. Okay? And so after you, and what we're showing here is a cylinder with a piston. If you drop the volume, the temperature drops. If you expand the volume, the temperature expands. Temperature goes up. If the temperature increases, it forces the volume to increase. Okay? So volume and temperature equals some constant. That's how we get this straight line. But this comes out to be the most practical form of the equation, the kind that we can actually use. So the way that I would suggest, I'm going to require you to solve gas law problems. It's going to be a way that you can almost always get the right answer. Is that you're going to follow a set of problem solution steps. The first problem solution step is to list all the things you know and what you're trying to find. It's called listing the knowns and unknowns. And we know that there's a volume initially of 12 liters of this gas, right? So we'll say volume equals 12.0 liters. And we know that 12.0 liters has a temperature of 260.0 K. And then it says, what would the volume be if the temperatures change? So we're going to change things, and we're going to have a second temperature and a second volume. Okay? So that means this first temperature and volume, we need to label it differently. We don't need to have two V's with nothing that would show us to be different. But the new volume, we don't know. So I'm going to put a question mark here. And the temperature, we know to be, the second temperature, we know to be 280.0 K. So we're going to list all our knowns and unknowns. The reason we do that is you can look at this list of knowns and unknowns and figure out what equation to use. Right now we only have one, but later we're going to have several. All right, more than several really. Okay, so you can figure out which equation to choose to solve the problem by your list of knowns and unknowns. Because you know you need volume 1, temperature 1, volume 2, temperature 2, and that's what Charles' law has. So then you're going to list the actual equation. Choose the correct equation and write it out in this form, okay? So list your knowns and unknowns, write the equation that fits, then you're going to plug in the values you do know. We know volume 1 is 12 liters. We know that temperature 1 is 260.0 K. We know that equals to volume 2, which we don't know. But we know the temperature 2 is 280.0 K. Alright, list knowns and unknowns, write the equation, plug in what you know. Now we want to isolate the thing that's not known. Isolate the unknown. How would I get V2 all by its lonely little self? What would I do? Multiply by 280.0 K over 1 on this side, but if I do it to this side, gotta do it to the other side. Good. Somebody had a good algebra teacher. Well, you remember it anyway. Alright, from this point forward, it's stuff you already know. We've been using this in stoichiometry. What do we do next? Cross out. Simplify. 280K cancels 280K, doesn't it? That's an easy one. That gets our V2 all by itself. What else can I do to simplify? Okay. And now we just put it into the calculator and solve the problem. What goes things across the top are multiplied together, and what's on the bottom you divide in separate operations. Remember all that? Yep. Units we have left are liters. That equals V2. We need to round off, though. How many significant digits? 3. Underline everything after the 9. So we're rounding off. So we have 12.9 liters equals V2. Okay? What now? There he is. I just didn't make it big enough for you to see on the camera. Okay? So, list, write the equation, plug in the known values, isolate the unknown, cancel what you can cancel, and solve. You got that set of procedures to do that?
Put our homework on this thing, or
No, I want you to have it ready to turn in on a separate sheet of paper if I need to.